Okay, we're going to get started. Welcome everyone to the 2018 Robofest Exhibition Workshop. We are sponsored by DENSO, our gold sponsor, a longtime sponsor of Robofest, and we thank them very much. My name is Elmer Santos. I am the Robofest Assistant Director, and I'm going to be presenting the workshop tonight. This is the agenda. We're going to talk about the exhibition rules, then talk about some basic LEGO EV3 skills, and then go through some specific techniques using examples with interactions with sensors, the ultrasonic sensor, color sensor, accounting example. And then finally, we're going to go discuss project ideas and do a little bit of a brainstorming exercise. And hopefully with that, you can we'll have a good idea and be able to proceed with your exhibition project. Now, the exhibition competition, it's a very good competition because there's complete freedom to show off any type of autonomous robotics project. There's no specific theme. Requirement is that you must employ sensors and human to robot interaction is encouraged. The official public presentation is 4 minutes. There's also an interview with judges. There may be silent judges that may visit the team tables outside of the official period. There will be a People's Choice Awards at the World Championship, and then sharing online video of your project is highly encouraged. And if you do that, the judges will look at it before the competition. Next, I would just like to briefly go through the judging rubric, the criteria that is used. The first thing is STEM learning, something that shows some aspect of science, technology, engineering, and math, and something that is appropriate to the age of the participant. You also get credit for project idea and originality. There's an aspect where they look at the demonstrated performance, whether the performance is free from problems and whether it was impressive, the way it was presented, whether it's clear, visuals, that kind of thing. Teamwork, we encourage 2 or more for, I think it's 2 to 5 team members, and we want to see how well they work together. The robot design, of course, that the design is creative, effective, user-friendly, and sturdy. The complexity of the project, more complex a project that works is better. On the other hand, we really want the projects to work as intended. Practicality, are you portraying something that is useful and can be used in real life? Programming, we want the students to be able to explain the programming of their project. And then team independence, can they, does it appear to be the students' work? Yeah, maybe at this point I'd like to skip or jump to a example of an exhibition. Let me see if I can find that. Okay, let me just skip to this one. This is kind of an example of what you would see. Okay, hopefully you could you saw that. I'm going to jump back to the presentation, but hopefully that gives you an idea of what an exhibit is like. You may have noticed that there's a lot of kind of outside noise during these presentations, so that is one aspect to try to present in a way that people can hear, and that's understandable from perhaps a longer distance away than you might think. Okay, next we're going to talk about some possible wireless interactions. You can have a human to robot interaction, robot to robot interaction, a host computer to the robot, or just other, some other sort of devices to the robots. Some human to robot examples of interactions: waving your hands in front of a sonar sensor, clapping or making a knocking noise to activate a sound sensor, using a sound sensor but not reacting until you hear like a double clap or a double knock, using a flashlight to activate a light sensor, using color blocks to be sensed by a color sensor. We're going to go through an example of that in a few minutes, using gesture with an onboard camera sensor. Some examples of robot to robot interactions, using a special colored jersey, like a covering on over the robot to be picked up by a light or a color sensor. RFID, Bluetooth communications, very popular, a built-in feature of the EV3 or Zigbee, or using the onboard cameras to do some robot-to-robot communication or interaction. Okay. Next, we're going to go through some EV3 basics. This workshop assumes that the attendees have some knowledge and experience with the LEGO EV3. The robot we're going to use is similar to the one we used for the game workshop. It's a basic robot with a left motor, a right motor, 2 color sensors, a touch sensor, and an ultrasonic sensor. The wiring should be the same as this, the left motor in port B, right motor in port C. I hope most of you know that the motors go into the lettered ports and then the sensors go into the numbered ports. So let's see, what was it? The left color sensor is in port 2, the right color sensor in port 1, touch sensor is in port 3, and the ultrasonic sensor in port 4. And then please note that if you're using the retail version of the EV3, it comes with an infrared sensor, which is a bit different than the ultrasonic. And if you're using the home edition of the software, the EV3 software, you will also have to, you may have to do some additional steps to be able to use the ultrasonic sensor. Also, please make sure that you've got the most recent version of the firmware on the robot, which is the 1.3.2 if you're using the educational version, or 1.09e for the home version. Okay, hopefully you can see my cursor. Just want to go through some brief features of the EV3 brain or brick. There we got the LCD screen. Basically have 4 menu screens, which denoted here. You can navigate with these buttons labeled 1, 2, 3, 4. The 3 buttons generally move you up and down, left to right. The 2 button is usually an OK or an enter button. And then the 1 button here is the back button, if you want to stop or to go back. Okay, we're going to cover some basic skills for EV3 loops, which repeat what's in them. Decision blocks, also known as switches, or if-then statements or if-else statements. Those are all the same things, all examples of decision blocks. We're going to talk about different sensors. We're going to talk a bit about variables. My blocks, which are ways to represent a large number of blocks with one single block. Parallel sequence beams, data connections, and some other things. Okay, moving on to the first exercise. It's an interaction with an ultrasonic sensor. We're going to use an ultrasonic sensor with sound and move blocks. As I mentioned earlier, if you have the home edition, you need to download, or you may need to download the programming blocks and import them into the software. This is how you do it. You go to lego.com, get the download, and then in the EV3 software, you go to tools and block import, and that should get you rolling. All right, this is the first program. It uses the ultrasonic sensor to sense something in front of it and play a sound. Yes, I'm going to share with you the program in the EV3 language. This file is available on the robofest.net website under Tech Resources. But I encourage you to create these blocks yourself using the palette below. Yeah, so on this one, this example is you have an infinite loop, repeat forever. And then inside is a switch, which looks for an ultrasonic sensor. Ultrasonic sensor, centimeters. It's looking for something that's less than 15 centimeters, and if it sees it, that's what the check mark is. It will play a 440 C notes for 1 second. If not, nothing happens. Okay, and I have an example. Let's see. Show you how that works. It's the one I have to start with. Okay. All right, so hopefully you can see that. All right, as I put my hand in front of it, it makes a beeping noise. Right, so pretty simple. That's an example of a human to robot interaction. So lots of different ways you can use that. Okay, here's another example. This actually does the same thing, but it's event driven, meaning that nothing will happen until you put your hand or it senses an object less than 15 centimeters away. So you can achieve essentially the same thing in two different ways. One using a switch, one using a weight, W-A-I-T, a weight block. And this all depends what you want. If you really you want the only thing to have that'll let you go to the next step is to sense an object, and you would use the event driven. If you want some other options, and I'll show you what the advantage of you doing it with a switch would be a little bit later. So two different ways to get essentially the same thing. Okay, the next exercise, we're going to add motors to the interaction. So we have the same repeat forever loop. We look for the ultrasonic sensor to detect something less than 15 centimeters. It plays a note, and then the robot will start moving. It moves backwards. This is the move block. Negative direction, one rotation, waits 1 second, and then it waits until the sensor sees something greater than 15 centimeters, and then it moves forward. So basically what will happen is the robot will move back if the object's detected. It'll wait till no object is detected and then move forward, and then it just keeps on repeating. All right, so let me show you an example of that. Let's see. There you go. It moves back, then moves forward if there's nothing in the way. But if there is something in the way, it'll stay until it is removed. Yes, I'll show you that one more time. All right, so again, that's another example of robot or human to robot interaction. Next, we're going to go through an example of math calculations. That's something that's, computers are very good at and would be good to incorporate into your exhibition project. So we're going to show an example that we use the EV3 brick to count. So they're called counters in computer programming. We will count how many times the sound sensor has been activated using a variable. Okay, I'm going to jump over to the programming environment. Hopefully that's be a little clearer. Hopefully most of you know to move around in in EV3 language, what you have is actually a project folder. It's multiple programs can be put into one file. So in this exhibition file, they're actually, or project, they're actually a lot of individual programs inside. So we're going to go to one called count. That's how you do it. So in count, let's see. We still have the repeat loop, repeat forever loop, I believe. Yeah, still repeat forever. Still looking for an object that's less than 15 centimeters. But we also are introducing the idea of a variable. So a variable, as the name suggests, can vary. And it's used to store the value of, to store different values that can change. So the way it's used here is we first initialize the variable. We set it to 0. So if you look here, you can read or write. So in this case, we're writing, which means we're telling the variable what its value is. So we're telling it it's 0 to start with. Then we start our loop, and if the sensor detects an object, we now read. We see what we get the value of the variable. We put into a math block, which is here. And then with a math block, you can do any mathematical operation. In this case, we're going to do a simple addition of 1. And then we're going to take the result, and then we're going to store it. We're going to write it to the count variable. So that's essentially it for counting. You basically initialize the variable. Each time you want to add 1 to the count, you read the variable, add 1, and then write the variable. In this part of the program, that's how we can see what's going on. This reads the count variable, displays it to the EV3 brick, and then so you can see the count. And then what this is a delay. So what happens with the robot is the repeat loop is executed very, very fast, and you don't want it to get multiple triggers. You want to count only when you intend it to count. So there's a slight delay to avoid double counts or multiple counts. All right, so that's how you count using the Lego EV3, and I will show you an example video. All right, here we go. Hopefully you can see it. There's the counter in the display. See, it's up to 4. We'll try it one more time. Yeah, blow it up. Yeah. There's the counter. Yeah, it's hard to see right now. It's 0. Right, 1, 2, 3, 4, 5, and so forth. All right, so back to the presentation. Okay, next we're going to talk about loops and switches, logic flow, and trying to make the robot stop, as I like to say. So to do that, you need what they call an end condition. So in the loop, there are a multitude of ways to replace the repeat condition with a condition that will allow it to stop. You can use time, count, rotation of a motor, sensor input. Here, let me show you that in the Lego language, so a little clearer. Okay. Count 2 is the example of this. In our original version, we had an infinite loop, but I've replaced that with a count. So after, a timer. So after some time you specified, it will stop counting. That's one way to stop it. And as I was saying, you can use all kinds of sensor inputs to make it stop. All right, so that's an example of stopping a loop or terminating a loop that they sometimes call it. And then I'm not going to go through this exercise in detail, but you can try to see if you can make that count program stop after 10 counts. Okay, what I would like to talk about though is nesting switches. And nesting basically means something like this. You have one switch and then you have another switch inside a switch. And what that allows you to do is look for multiple conditions at the same time, or virtually the same time. So this is a program that plays different sounds depending on whether the ultrasonic sensor is tripped or activated, or the touch sensor is touched. If the ultrasonic sensor is activated, it plays a C note. If not, if a touch sensor is pressed, it plays a different note. And then if neither is pressed, it does nothing. And then it repeats. And I believe I have an example of that. Let's see. Yeah, here it goes. Okay. Okay, that's the next video. Okay, so that was an example of nesting switches. So that's a pretty valuable tool. If there happens to be anyone listening that's working on the game this year, the nesting can help you with the game as well. One good example of nesting would be if you're trying to write a section of the program, which on the one hand, you're trying to follow the edge of the table, but at the same time, you want to be looking for the bottles. What you would do is you would nest the conditions. The first one might be perhaps if you sense an object such as the bottle, then you want to sweep it off the table. Otherwise, follow the edge of the table. Yeah, so nesting is a very important and valuable concept. Okay, on to the next exercise, color sensor, using the color sensor. And this example is going to use the color sensor using Lego blocks, colored Lego blocks, that is. The Lego EV3 sensor has multiple modes. It can work as a light sensor, which essentially reflects, shines a light and then reflects or then measures the brightness that's reflected back. And that's very important for things like edge following or line following. I think I might go through a brief example later. But then for this exercise, we're going to use it in color mode. It senses different colors. And in color mode, the sensor will output a number corresponding to which color it sees. So it'll be 0 if it's no color, 1 if it's black, 2 if it's blue, 3 if it's green, 4 if it's yellow, 5 if it's red, 6 if it's white, and 7 if it's brown. The Lego language actually makes it even easier for you. Rather than putting a number, it actually shows you the color. So I'm going to jump to the programming environment, show you how this color program works. Okay, so what we have again is a infinite loop, repeat forever, and then a switch. And then the switch has in this case has multiple conditions. It says, yeah, your color sensor in port 2. What color does it measure? If it's red, plays a sound file that says red. If it's green, plays a sound file that says green. If it's blue, it plays a sound file that's blue. And if it doesn't sense anything, it doesn't play a sound. All right, so let's go to an example of the video of the example. Here we go. Oops. All right, so that was I can just play it one more time. All right, so that was a simple example. One nice thing about switches in the EV3 environment, it's really easy to add more conditions. If you want to add a condition, you simply hit this plus button to add a case, they call it. Okay, if I do that, you can see that it's added another case. You don't want to leave a question mark yet. You should make it something. So say if I wanted to read yellow, I could just select yellow and then go down to my sound block and then put an appropriate sound. It's a file. Yeah, lots of sound files in the Lego environment. Colors. Yellow. There. Right, so if I loaded that program, it would also be able to detect a yellow block. If anyone goes on or works on something called World Robot Olympiad, it's an international competition. Color sensor is an essential part of it almost every year. There's always some aspect of using the color sensor to help to help the robot navigate and score points. Okay, I'm going to go back to the presentation. Okay, using the display, I showed one example earlier, but we're going to go into some more detail now. You can use a display to display letters, text, shapes, or an image. So it can be used to display messages or show data. And one thing you could do as an example, in this case, you could display the name of the color in each case for the previous exercise, as well as making the sound. And then one thing to note about the display block, the selector here is for text, shape, or image. You can tell what location on the screen you want to put the message. And then the message here is actually, it's under in the upper corner. And then you can choose the size of the font. And then this one's important too. It tells whether to clear the display or not to clear the display. So that's a good thing for to incorporate to exhibition projects as well, the display function. Okay, next we're gonna just briefly go through an example how to use the light sensor to detect the edge of a table. A very useful thing in the EV3 programming environment is a sensor screen. Let me show you how to do that in the software itself. Yeah, I don't have a robot plugged in, but if I did, in the screen, you could go to here and it would display the value of the sensors that you see in the presentation. So keep that in mind. If you, it's really good for debugging purposes, the sensor window. Oops. Similar to the ultrasonic example, there are different ways to detect the edge of a table. You can use something that's event-driven, like this. Basically, turn the motors on going forward, wait until see something dark, something less than 20%, and then stop. Or you can use a loop. Or you could actually use a loop with a switch as well. But they're multiple ways of doing similar things, or pretty much the same thing in programming. All right, next we're going to talk about my blocks. My blocks are very useful because some programs can get very large and very difficult to understand. So to alleviate the issue, the EV3 software has a MyBlock builder to create custom blocks that replace sections of your program. And the same MyBlocks can be reused in multiple places in your program. And they can actually be copied from one program to another if you want. So the example we used in this workshop was we took the color sensor example, right? You can see how it's this kind of large switch, and we can represent it by one MyBlock. And I'll show you how to do that. So the way you do that in the programming environment, you select whatever you want to represent by a MyBlock. You go to Tools, MyBlock Builder, give it a name, color, select the icon to represent it, and then you can hit Finish. And you can see that that large group of blocks is now represented by one block. And then anytime you want to use that block again, you just simply find it. Oh yeah, this one, and then pull it out. So for example, like if you were, say the task was you would go from one location to another and then read what color, the color of an object at that location, you could use this block to read the color and then add some code, some programming blocks that allow the robot to get to the next location, and then add another block. Yeah, so rather than having to recreate all these blocks each time you use them, you can simply use a MyBlock. So that's one example of using it. Line following or edge following, that's another place I've found very useful for my blocks. I'm trying to think of some other examples, but yeah. Oh yeah. So the other good thing, if your program gets very long, you can actually use the my block to kind of summarize what that part of the program does. And I don't really have an example of that here, but just even say you've got like a huge mission and it's divided into 3 parts, you can just simply put the first group of blocks into my block called, part 1. Yeah, for the game, for example, you can have one a big my block that said collect the balls, and then you can have another block that says find the box, and then another big my block that says dump the balls. And by doing something like that, it helps. Well, it helps the programmer kind of organize the code, but from a presentation standpoint, it helps someone else that's looking at it that's not as familiar to understand what the program is doing. So my blocks can be very useful. I encourage you to try them and to use them. Yeah, there's some of the detail I just went through. Okay, next thing, we're going to go through something called multitasking, or using a parallel sequence beam. So this is what a parallel sequence beam looks like. In addition to kind of your main sequence beam that you usually see, you add more things that run in parallel. So you can do multiple things at the same time. So for example, you can flash a light or play sounds. So you see that this set of blocks is flashing a light, it goes green, waits a 1/10 of a second, and then flashes red, it repeats. And at the same time, somewhat independently, you could be playing sounds. You can add a third one like this, and as many as you can fit and keep track of. Yeah, so multiple or parallel sequence beams are really useful. If anyone ever does the Robofest parade, what you generally want it to happen, or what you often like to happen, is the base of the robot will be following a parade route, like a line. But at the same time, you wanted some other secondary, some sort of motion of a device that's on top, and you want those to be independent. So that's an example where you would have the following the line, the parade route in one section, one sequence, and then have a second sequence that has repetitive motion for the arm or the thing that's on top. Something that might be spinning or moving back and forth. But that's a way of being able to control those things independently. The parallel sequence beams is another very useful thing. Another thing that would be good to incorporate into your exhibition project. Okay, next we're going to talk about generating ideas for the projects. Okay, some project ideas coming right from the judging rubric. Something that demonstrates STEM learning: science, technology, engineering, or math. Original and creative. This is something from in my background, from trying to automate things. You want to automate things that are dirty, difficult, or dangerous. So for example, in my background, I used to work as a manufacturing engineer for General Motors. One of the dirty, difficult, dangerous jobs was welding. There you had these heavy resistance welding guns that you would have to sling all day. And now almost 100% of the welding is done by robots. Another area that's been heavily automated by robots is the painting function. Painting used to be all done by hand, and now it's almost 100% automated. A good idea for your exhibition project would be something that solves some of the issues you see today. something that's entertaining, that adds visual or audio interest. And something I like to do, and I encourage my teams to do, is to keep asking the question, how can robotics be used to demonstrate your idea? Yeah, so to expound on some of today's issues, there are sustainability issues, and robotics or automation can be used to automatically monitor and adjust processes that helps the environment and sustain resources. It also enables better, more efficient use of resources. Humanitarian assistance, there are lots of things in the news. There are lots of disasters, floods, and automation, robotics can be used for recovery, rescue, help for the refugees perhaps. Safety, security, and defense. One of the probably a difficult job for a human to do is to be watching something all the time, or trying to we have a saying in manufacturing that 100% of inspection is only, I forget what it is, 80% effective or something like that, but it can be much higher if that inspection is automated. So robotics can be good illustrate, a project might be something that involves safety, security, or defense. And then lastly, difficult environments. I talked a little bit about the auto factory difficult environments, but there are other ones. Water, really hot environments, really cold environments, toxic environments. Those are good applications of robotics, and would be possibly good ideas for an exhibition project. Okay, next I'm going to talk a little bit how to use robotics to demonstrate your idea. Automating task. If you can show that a task can be automated, and we'll go through some examples in a few minutes. How robotics can solve a problem or provide benefits, something that do it quicker, more frequently, more reliably, something that provides data, speed, arrival time, temperature. And as I said earlier, that's one great thing about robotics. It doesn't get tired. You can run it 24 hours a day, and you can get a lot of good data from it. And if you can demonstrate some application of that, that would also be good for an exhibition project. Okay, next we're going to talk about some ideas from previous years. If you want to go through the actual videos, examples, they're available at robofest.net. But I'm just going to give you kind of a summary. Previously, someone had done a robotic blimp project, blimp that was automated. That was very entertaining. A skit, Tourist in the Hair. So we actually used robots to do some performing arts. Kind of continuing on that performing arts theme, someone programmed a robot to play the piano. Furry friend feeder. This was an example of how you can use robotics to take care of your pet. A GPS, a global positioning system guided robotic boat that had monitoring and measuring ecological data. A robot that modeled the human body. I remember this one. It was a Lego violin, which is very entertaining. It had really good sound, and it used all Lego sensors to create that sound. So it's very, very impressive. Here's a good one. Robotic landmine seeker. That was done a few years back. Robotic fish tank keeper. Another robotic music. I think this is a xylophone. Oh, I see. Yeah, this actually read a musical score and then played the music. That was a very good one. Here's one where robots used to play checkers. And then here's some more recent ones. Robotic fire assistant. This one assisted firemen and specifically could cut holes in the roofs of burning buildings, which is one of the most dangerous parts of the fire rescue. Here's an autonomous tank exhibition project. And here's one that's using the swarming concept. That you may have seen that with drones, but you use multiple, automated devices working together. They have to communicate with each other and work together to solve a problem. And then here's another kind of performing arts, medieval themed exhibition. Yeah, this one used a Wii remote control to perform medical procedures and collect data. Here's an autonomous vehicle, intelligent car project. Here's a good one. It's a smart stick for the blind. So you use robotics to help the blind. Yeah, this is one, I showed you the beginning of that project. That was called ZooBots. It was designed to take care of zoo animals and keep zookeepers and zoo animals safe. Okay, here's another musically themed one. It combined Lego robotics and a computer with Guitar Hero. Yeah, and that's I guess that's it for the examples for now. All right, next I'd like to just go through a bit of a thought brainstorming exercise for an exhibition project. Just show how you can apply some basic robotic concepts and create a project. All right, so here's actually something from the game this year. Uses a table. One of the basic tasks is a robot navigating around the table. Let me share that video. So it's pretty easy to program a robot to travel around the table. But this would also, I guess, in my opinion, this would be a good basis for an exhibition project, because you could design it to be pretty reliable. It goes in a loop, so it'd be good to do a kind of a constant demonstration. And then I believe it's something that can also be enhanced with other things. But yeah, I'd like to kind of, I'd like everyone to kind of think about that video and try to think about how you might turn that into or incorporate that into an exhibition project. So I'll give you a few seconds to kind of think about that. All right, hopefully some of the ideas have kind of are coming to you from some of the stuff I've shared so far. But here's some of the ideas I thought of. So you've got a robot traveling around the table. You could have like a transportation theme. You might be able to show an example of mass transit or ride sharing, or even this individual travel. Autonomous vehicles, right? I think you should be able to see how you could use that concept to try to illustrate how an autonomous vehicle could work. Search and rescue, exploration, truck convoy. Yeah, that's something I just read about recently. The idea is to have trucks travel in a convoy. The first one might be driven by a person, but the next few are automated, and that would save, be more efficient and save money. And these are some of the ways that at least I came up with that you could enhance that into a project, right? You could program the ultrasonic sensor to detect objects in front of it and then automatically stop, similar to like our parade competition, right? But that's also a kind of illustration of how an autonomous vehicle might work. Add a second robot, a third robot, show that you can, multiple robots could kind of share the same space and not run into each other. You can use the robots to measure distances, and we're not going over that in this workshop. But if you look on Robofest Net, there's some information that will show you how to do that. You can also measure speed, multiple ways. You can use the rotation sensor. You might be able to use the ultrasonic sensor to measure speed. Come up with some sort of scheme where you can detect the location of the robot. One way you could just use a second EV3 unit, and you just use the first exercise for this workshop. You point the ultrasonic sensor at the one of the sides of the table. So when the robot passes, it'll be less than 15 centimeters, and then it can give a beep, and that would be an example of using robotics to detect the location of the robot. You can display various parts of data. You can do things with the status lights or sounds, and then you could add human interaction. And we went through a number of examples of how to do that using the ultrasound, the touch sensor. There's also a sound sensor. There's an example in the more information section. So hopefully this gives you an idea how you can take kind of a basic concept and then enhance it, make it a more interesting, a more complex exhibition project. Next, I would also like to talk about the visual arts aspect of exhibition projects. You could have a robotic system that control puppets, for example. Then I'd like to share with you something that's kind of a visual project, and the question to keep in mind, is this a valid Robofest exhibition project? So let's see if we can get that. Oops. Let me make sure I'm sharing that. Okay. All right. Here's the project. Okay, so that's the example. The question is this a valid Robofest exhibition project? So I guess what would determine that is, if you go back to the judging criteria, does it show some aspect of STEM? Does it use sensors? Yeah, that's probably the kind of the thing that would determine it. And it's a little hard to tell for sure. Yeah, it looks like it may use some sensors, but the more it satisfies the project, the more likely it is to do well as the exhibition project. Yeah, similar to some of these. Just if you get really kind of something that's more kind of on the arts side of it and less on the science, technology, engineering, math, it might be better to enter your project in the Robo Arts competition, which is similar to exhibition, but it's a little more slanted towards the arts. So kind of keep that in mind if you're doing something more visual. Yeah, again, if it uses a lot of sensors and math concepts, that it probably is a good exhibition project. But if it's more just more visual and not so many sensors, might be better off using it for Robo Arts. And there's some more examples you can go through and see what you think. All right, some other ideas for exhibition projects. There's a thing called data logging. This is something that requires the Lego education version of the software. And you can take any of the inputs from your sensors and then basically graph them. So for example, here's the output of a sound sensor that uses the data logging, and you could use that for a applause meter, for example. And I'm not going to go through the details of that, but if you're interested, it's in the additional notes section. Other sensors, some of these things that are not standard Lego sensors, you can find them in these places: mindsensors.com, which is the Robofest sponsor, Vernier, Codatex, High Technic, Dexter Industries. Some of these sensors are specialized and could be, unique. Something that may not be used by other exhibitions and could be good material for your exhibition project. And here are just some examples. Using accelerometer to log and measure your parents' driving skills. For less acceleration, the better, the smoother you are, the better driving skills, the better fuel economy, that kind of thing. I don't know, maybe either you're using some sort of a steering wheel mechanism or an accelerator pedal using, some sort of sensors. I guess an accelerometer is interesting here. And there are additional resources online. Again, you can find the webinar link and other additional information at robofest.net. All right, that's basically what I had for this webinar. I thank you for your attention. Again, we thank DENSO for sponsoring it. And at this point, if you have any questions, I can open up the line for questions. So I want to unmute the line. If there are any questions, please speak up. All right, I'm not hearing any questions, but if you do have some, what? Is there a question? No. Okay, if you do have a question, you can email me at esantos@ltu.com, or I'm sorry, ltu.edu. So any questions, please email me and I'll be happy to assist you. So once again, we want to thank DENSO for sponsoring this. Thank you very much for attending, and have a good evening. Thank you.